Hello everyone, welcome to Viterbi Bros. In today's video, we're gonna talk about sorting algorithms. So, there are many sorting algorithms that has been invented by computer scientists, but in this video, we only discussed 4 sorting algorithms that you have seen a lot in Introduction to Algorithms courses as well as EE355. So, the first one gonna be the selection sort, the second one gonna be the insertion sort, third one gonna be the bubble sort, and lastly is gonna be the merge sort. So, let's start with selection sort. And our goal is to sort this list into an increasing order. And the algorithms of the selection sort gonna be the following. At the beginning, you're gonna pick a starting number. And then you scan to the right of that number to find the smallest one. So let's say I'm gonna pick the first slot. This is gonna be my starting number. And since this is gonna be the first slot, so you have to find the smallest number in order to fit it in. So let's say I'm scanning to the right according to the algorithms, and the smallest number you found is X. And if you found, you're gonna swap it with the starting number. So I'm gonna swap X with number 10. So now X is gonna be on the front. And after that, you're gonna updating the starting number, and number 10 is our starting number. So we're gonna move to number 3 at our next starting number. And you're gonna repeat the same step until the list is sorted. So now, I'm gonna give you a military analogy. So let's say you're a commander of your military unit. And one day, you wanna sort all your soldiers based on their ID number in an increasing order. So this is gonna be the list. And each element here represents your soldier ID. 10, 3, 9, 1, 4, 5, 2, 6. So, you're gonna start at the first position. And now, you're gonna asking of your soldier, hey soldier, who among you guys are the smallest one? And this turned out to be the guy with number 1. So he's gonna say, sir, this is me, ID number 1. And after you found the person, you're gonna swap it with your starting point. And you can see the person with ID number 1 now is on the front. And the person with number 10 replace that person's position. So let's continue. After you finish the first slot, you're gonna move to the second slot. And now you ask your soldier again, hey soldier, who's the second smallest number? And this turned out to be the guy with number 2. And if you found, according to the algorithms, you're gonna swap it with the starting number. So I'm gonna swap and continue. Now you start at the third slot. You ask again, who's the third smallest number? Again, it's gonna be the guy with number 3. So I'm gonna swap it. Now you move to the fourth slot. And you found the fourth smallest number. It's gonna be the guy with number 4. You're gonna swap. And you start at fifth position. You found the fifth smallest. You swap. The 6th position, you found the 6th smallest, you swap, and then you done. And note that the yellow color here is mean the time that I already scanned the number. Let's try another example on your own to make sure that you understand selection sort. So, after we have some basic understanding of selection sort, now let's figure out the runtime. So in this time, our goal is to sort the following list in an increasing order. As a human being, or the commander example, when he tried to solve or to sort this list, he asking his soldier like, hey soldier, who the smallest one? And then all the soldier gonna compare the number among themselves, and the one with the smallest number gonna step out and then tell the commander, hey commander, this is me, ID number 1. But the machine doesn't work like that. For the machine, when it's solving the sorting problem using selection sort, it actually have to scanning to each element in order to find the smallest number. And then it's gonna do the swap thing. So, let's solve this problem under the view of the machine. So, the machine gonna start scanning at the first position, which is number 9. And the yellow color mean the number that we already scanned. So, we just scan number 9. And for the rest of the list has a white color. So this means the machine has not scanned it yet. Therefore, number 9 is the only number that the machine has seen so far. So, the smallest number is actually number 9 itself. So, we're gonna update the min variable right here with number 9. So now, let's start scanning to the right. You're gonna scan to number 2, and you're gonna compare with the mean. So, currently, the min is at 9, and 2 is less than 9. So, we're gonna update the min with number 2. So, min equal to 2. So now, you just keep scanning. You have number 5 right now. So you're gonna compare with the min. Is 5 less than 2? Seem to be no. so you're not updating the min. Now you go to number 1, and is 1 less than 2? Seem to be yes, so you're gonna update the min to 1. Now you're gonna scanning to number 8. Is A less than 1? No, so you're not doing anything. Now let's scan number 3. Is 3 less than 1? No. Let's scan to number 4. Is 4 less than 1? No. Is 6 less than 1? No. So now, your final min number gonna be number 1. Therefore, you're gonna swap number 1 with the first slot, or number 9. And this is how it looks like after the swapping. So after you filling the first slot, you're gonna start scanning at the second slot. So the machine gonna scan from 2. And since number 2 is the first number that is seen, so initially the min gonna be 2. So now you're gonna scanning to number 5. Is it less than 2? No. 9. Less than 2? Nope. 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 So therefore, in this case, you didn't swap anything at all. So after you're done processing the second slot, we move to the third slot. Initially, the min gonna be number 5 because this is the number that the machine has seen so far. So min equal to 5. Now you're gonna check number 9. Is it less than 5? Nope. 8. Are you less than 5? Nope. 3? Yes. So update the min to 3. 4? Nope. 6? Nope. So you're gonna swap your number 5 with number 3. So now let's start the fourth slot. So 9 gonna be your initial min. Min go to 9. 8, are you less than 9? Yes. Update the min to 8. Now you go to 5. Are you less than 8? Yes. Update again. Now 4, are you less than 5? Yes. Update to 4. 6? No. So your min is number 4 and you're gonna swap number 9 with 4. So now, let's go to the fifth slot. Initially, the min gonna be 8. 5, are you less than 8? Yes. Update to 5. 9, no. 6, no. So, gonna swap 8 with 5. Now, you go to the sixth slot. Initially, the min is gonna be 8. Is 9 less than 8? No. Is 6 less than 8? Yes. So, we're gonna update the min with number 6. So, number 6 gonna be swapped with number 8. Now, we're gonna move to the seventh slot, which is number 9. Initially, the min is number 9. Is A less than 9? Yes, so we're gonna update the min with number 8. And then we're gonna swap them together. Now, you add the last position. And the initial min gonna be number 9. But you have nothing left to scan or write. So at this time, the program do nothing. And this is also your final solution. The list is sorted. So now, this is a summary of what we just did. And you can see at the beginning, is it unsorted until the bottom is become sorted. So when the machine perform the selection sort, it actually have to scan through the list in order to find the smallest number. Therefore, the runtime depends on the number of time that the program on the machine have to scan through the list. So it's gonna be the summation of all the yellow color box. As we agreed before, the yellow color box mean the machine already scanned the given element. So you can see the first case, there are like 8 yellow box, so it costs 8 times to scan. The second is gonna be 7 times to scan due to 7 yellow box. There's gonna be 6 because there are 6 of them. 1, 2, 3, 4, 5, 6. It's gonna be 5 the next layer, and you can see it's dropped until 1 yellow box left, which is number 9. So when you add them up together, you add from 8 until 1, the total gonna be 36 times. And you can see number 8 right here is actually the length of the list. You can see on the top, the list has the length of 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. So the 8 number right here is actually represent the length. So for n element, the runtime gonna be the summation from n until 1. So we're gonna write in more general case. This runtime for the 8 element list, now we write in more general case. Let's start from n until 1. And this turned out to be simplified into n plus 1 times n over 2. And you're gonna do the distribution. So it's gonna be n squared plus n over 2. So at n go to infinity, the runtime gonna be O(n) squared. You just ignore the n term because the n squared growing faster than the n term. So your runtime solution gonna be O(n) squared, which is the worst case runtime of selection sort.